Why, hello there, math magicians. We're going to learn something new today, so let's jot down some notes. Because you know you don't remember everything your teachers tell you. Let's title this Notes, Lesson 11.4, because that's the section this matches up with in your textbook. And the topic, multiplying and dividing rational expressions. All right, let's get going here. First thing, there are 3 things you need to remember. Three things that you need to remember. All right? So the first thing is how to multiply fractions. All right? So if you just had fractions, no algebra, let's say you had 3/4 times 1/6. Okay? In multiplication, you are allowed to cross cancel, long as it's on the numerator and denominator. So you can cancel 3 and 6. 3 goes into 3 once, into 6 twice. And then you just multiply straight across. 1 times 1 is 1. 4 times 2 is 8. Alrighty, so that's something you need to remember, a skill that you've learned in the past. When it's multiplication, you are allowed to cancel from numerator to denominator, either one above the other or one across from the other, okay? Only in multiplication. All right, so maybe let's jot that down. You can cross cancel. You can cross cancel when it's multiplication. All right, next, number 2. You need to remember how to divide fractions. We've talked about that recently. So 1/3 divided by 5/9. The rule for division of fractions, keep the first fraction the same, change it to multiplication, and then flip the second fraction. So you flip the second fraction. Now, once you now have it multiplication, you're allowed to cross cancel. Okay? So you can cancel 3 with 9. Long as one's in the one's in the bottom, one's in the top and bottom, not side to side, top and bottom, and it has to be multiplication. You can't cancel when it's division. All right? Not when it's division, but only after you flipped and turned it to multiplication. All right, 3 goes into 3 once and into 9 3 times. And now just multiply straight across the numerator times numerator and denominator times denominator. So 1 times 3 is 3, and 1 times 5 is 5. All right? So division, to divide, you flip the second fraction. You flip the second fraction and multiply. Once it's been flipped and changed to multiplication, you are allowed to cross cancel. All right, the third thing you're going to have to remember is what I just taught you yesterday. You're going to probably have to do a lot of factoring, and many times it's the first thing. So factor first. Factor first before canceling. Okay? Let's write that in there. Whoops. Factor first before canceling. All right. Let's try some examples. So here we go. Part B, examples. All right, number 1. let's say you have 2n minus 1 all over 4n to the 5th times 2n to the 3rd over 3. Okay, this is multiplication. We are going to be allowed to cancel, but we have to factor first. Okay, so here we go. Can 2n minus 1 be factored? Is there a GCF in 2n minus 1? No. No, there's not. So 2n minus 1 is just going to stay 2n minus 1. And then times, so we'll just write the next thing, this right next to it, because we're multiplying, you multiply straight across. 2n to the 3rd, you might write that as 2, and then n. You can put the dots between it if you want. That's up to you. Underneath, we have a 4n to the 5th. So 4 is 2 times 2. And then n to the 5th, 1, 2, 3, 4, 5. And then we have that times 3. Okay, so everything's being multiplied here. Everything's being multiplied. The part that's being subtracted, that goes all together. You can't split that up. So you cannot cancel this 2 and this 2. No, no, no. Because that's a 2n minus 1. All right, that's not just a 2. It's a 2n minus 1. Now, we can cancel this n with this n. 1, 2, 3. We can cancel this 2 with this 2. And what you're left with in the numerator, the only thing you're left with in the numerator is 2n minus 1. And underneath, you have a 2, a 3. 2 times 3 is 6. And then n times n squared. All right? So the 2 times the 3 was 6. And n times n is n squared. And that's your final simplified answer. You cannot cancel the 2 and the 6. Now everything here is being multiplied, but up here you have subtraction. All right, so that all goes together. Now don't forget your excluded values. So you look at the denominator, just the denominator, and it can never equal 0, so we can't have, n can't be 0. Because if you multiplied by 0, the whole thing would be 0. All right, let's try another one. Number 2. Let's say you have k minus 3. Now remember, if I go too fast, you can pause this video. You can also go back and rewatch it at a later date. All right, k minus 3 over k squared. K plus 2 over k squared minus k minus 6. Okay, here we go. Factor first. Factor first. So can k minus 3 be factored? No, there's no GCF. It's not the difference of perfect squares. So k minus 3 is just going to be k minus 3. I'm going to write it underneath here because I have more room. K minus 3. And notice I'm putting that in parentheses. All right, now times k plus 2. Is there anything that can be factored with k plus 2? No. And since it's times, I'm going to put them right next to each other. Now underneath k squared, I could write that as k times k. And that's times. Now this is a trinomial. That can be factored. All right? And we'll do the X trick. We'll go over here. What multiplies to give you negative 6 and adds up to negative 1, right? Multiplies to negative 6, adds up to negative 1. I think that has to be negative 3 and positive 2, right? So now I can factor this trinomial into k minus 3 and k plus 2. And notice I just put it right next to it because it's times. It's being multiplied. Now I can cancel. So I factored first. Now I can cancel. Now with addition subtraction, you're canceling the entire quantity. So there's a k minus 3 and a k minus 3. The entire quantity. K plus 2, k plus 2. The only thing you're left with is this k times k, and it's in the denominator. So keep it in the denominator. That'll be 1 over k squared. Because remember, when you're canceling, it's just big giant ones. So when you cancel, it's a 1. There's a 1. Alright, so there's your final answer. And now don't forget excluded values. So you look at the denominator only, just the denominator. And k can't be 0. It can't be 3. And it cannot be negative 2. Alright? Okay, we'll try 2 more, but I'll put it on the next video.